Hi, this is Electronics. In this video I will present you what is a diode and how to make direct current from alternating current. Definition: the diode is a passive nonlinear electric component which allows the current to flow in only one direction. You can imagine it like a valve which would allow the water to flow in only one direction, but with certain losses which later I will explain. Nonlinearity means that as the voltage rises, the current does not rise accordingly. At a linear component, for example the resistor, if the voltage rises, the current rises at the same time. The diode doesn't have a resistance, so it won't obey the Ohm's law. Ohm's law says that the current equals voltage divided by the resistance, but in this case the diode has no resistance, so we can't use Ohm's law at the calculations. Before using a diode in a circuit, the electrical characteristics must be verified in the datasheet. The important ones are the maximum AC RMS and also DC blocking voltage, maximum rectified forward current and the maximum forward voltage drop. This is the datasheet of the 1N4000 series diodes. The voltage drop is usually 0.7 volts for the normal silicon diodes, and it means that the rectified voltage is 0.7 volts less than the input voltage. The forward voltage drop does not change with the value of voltage applied to the component. This means that the diode won't conduct any current until the voltage reaches at least 0.7 volts. This forward voltage drop also generates heat from the dissipated power, so consequently as the current rises, the dissipated power also rises correspondingly. To calculate the dissipated power, the voltage drop must be multiplied by the flowing current. For example, 0.1 amp multiplied by 0.7 volts equals 0.07 watts of heat dissipated. As I mentioned earlier, as the current rises, the dissipated power also rises, so at 1 amp current flow, the dissipated power is 0.7 watt, which can already generate some heat. Always do research in the datasheet for the maximum allowed current flow before using diode. For example, for this 1N4000 series diode, the maximum supported current flow is 1 amp. It has also reverse breakdown voltage, which is a limit of reverse voltage it can block before it breaks down and starts to conduct. In the datasheet this is mentioned as maximum blocking voltage. Exceeding this value causes the diode to stop blocking the reverse voltage. This is a VI curve diagram of the diode. It shows on the right side the forward voltage and when it starts to fully conduct at around 0.7 volts. On the left side the reverse breakdown voltage when the diode fails to block the reverse voltage, which is around 700 volts RMS. If the diode's forward voltage drop is significant for the circuit, then transistors can be used. These are connected in the same way as the diodes and controlled in sync with the AC wave, but this is far from the purpose of this video. The Schottky Diode is also a better option if the voltage drop is important, because it has a lower forward voltage drop and higher switching speed. It has its own drawback too. The reverse leakage current is higher than the normal silicon diode. The best choice of diode depends on the circuit in which it will be used. Presentation with the oscilloscope. With the oscilloscope I will show you how the diodes work in a circuit. Using one diode, a half-wave rectifier circuit can be created. This rectifies the half of the sine wave. This means that only the half of the power provided by the transformer is used. To use the full potential of an AC sine wave, a full-wave bridge rectifier must be used. It is made from 4 diodes and rectifies the full sine wave into DC. Now you can see the output of a bridge rectifier. You can buy these packed into IC package with 4 pins, mostly ranging between rated voltage of 100 and 1000 volts and maximum current rating from 1 amp up to 25 amps. Other use of diodes. In some cases the diode is used for its own negative aspect, the forward voltage drop. It is used in circuits where a voltage drop is necessary, biasing, limiting and other kinds of usage. For example, it is used in amplifier circuits and ICs like the TDA 2003 amplifier IC. This is the block diagram which you can find in the datasheet of the IC. Here are the diodes and also the Zener diodes used in the integrated circuit. Thank you for watching. I hope this video was informative, and don't forget to leave a like if you want to see more videos like this.